Section 6.2 is about finding the volume of an object generated when you rotate, or solid generated by rotating an area about the x-axis. So let's do this example to get an idea of what we're looking at. The first example is find the volume of the solid obtained by rotating about the x-axis the region under y equals square root x from 0 to 1. Well, it's easy to sketch the graph of y equals square root x and see the pink area is the area that we're rotating about the x-axis. Remember, when we were finding area under a curve, we talked about the integral as the limit of the sum of the areas of all the rectangles as the number of rectangles approached infinity. Well, now when we rotate that rectangle, it's going to start to look more like kind of a 3D disc. Let's see if I can draw. When we rotate. So we're going to find the integral is going to be the area, it's going to be the volume is going to be the limit of all of the volumes of these little discs added up together, the limit of the sum as the number of discs approaches infinity. So, but we just find that by integrating. And if you think about how you would find the integral of this disc, you would find the width of it, or if you put it on its other side, the height. If you looked at it as a cylinder, it's a cylindrical disc, and you would take that times pi times the radius squared, which is the area of this face of the disc, pi r squared. So when we look here, you can notice that this height here, or this here, will be the r of the disc. It will be the radius of the disc. Well, that value, or that height there, is just the f of x value. So what we're going to integrate, it's easier if you see me write it out, it's the integral from 0 to 1 in this case of the area of a face of the disc, which would be pi times f of x squared times the width of the disc, which is our dx, our change in x. So now if we integrate this with using our initial problem here, our f of x is the square root of x. So we've got the integral from 0 to 1. Pi is a constant coefficient. Pi is a constant and a coefficient, so it can pop out in the front there. We've got square root x squared dx. Simplified a little bit more, so 0 to 1. Square root of x squared is x dx. Well, this is a fairly easy integral, isn't it? Give myself some room. Be pi times x squared, not pi squared, x squared over 2 evaluated from 0 to 1. So that equals pi times 1 squared over 2, which is pi over 2, minus 0, or pi over 2. Pi over 2 is the volume of the solid obtained by rotating this pink area around the x-axis. Pause here and take the notes you need to take. The next problem I want to do, this is the first problem from your homework on page 362, number 1. It's a pretty straightforward problem. Again, we're rotating the area bounded by y equals 2 minus 1/2 x, y equals 0, which is just the x-axis, and this line x equals 1 and x equals 2, these two lines. So those two lines are just going to be our boundaries, and that's going to be a pretty easy one just to draw in. So let's draw in those vertical lines first. At x equals 1 and at x equals 2. Well, it's close enough to x equals 2. It's not exactly on it, but that's where it should live. And the x-axis we can already see. And then let's graph the line 2 minus 1/2 x. So we notice that's a linear equation. We can graph it by hand. Its y-intercept is going to be at 2. and it's got a slope of negative 1/2, so we could even count down 1 over 2. And there's the line where it intersects right there. So it's pretty easy to see that this line is going to go right like this. And here's your area that you're going to rotate about the x-axis. So when you rotate that around, let's look at our rectangles. You can see that the rectangle is going to turn into a disk, and its height is going to be that f of x. So we integrate from 0, not from 0, from 1. From 1 to 2. Well, go ahead and put the pi out here, and we're going to go pi times the radius of the disk squared. The radius of the disk is going to be like the height of the rectangle. So 2 minus 1/2 x, the quantity squared, dx. Take a minute to work this out. We'll come back with the solution. Pause it if you need to. Okay, down below you can see the solution to this problem. The important thing to remember is that first we need to do a little bit of algebraic simplifying. So square the binomial before you integrate. And then once you are ready to integrate, this is what it'll look like. Evaluated at each of the numbers, you should get 19 pi over 12. In this next problem, we're trying to find the volume generated by the solid bounded by x equals 1, x equals 2, y equals 0, or the x-axis, and y equals 1 over x. So what we need to do is graph those things that we already know. Do a rough sketch of what we've got to graph. Pause and do that. Now that we've got a sketch, we can see we're looking at this area here, rotated around the x-axis. So we're integrating from 1 to 2. Put the pi out in front. Our radius of our disk is going to be our f of x here, 1 over x squared times the width, dx. So we can evaluate this pretty easily. Simplify first before you integrate. So 1 squared is 1 over x squared. So 1 over x squared is x to the negative 2. That's easier to integrate. Then we got pi times x to the negative 1 over negative 1. Evaluated from 1 to 2. You can make that look a little easier to evaluate, if that helps a little bit. And now let's evaluate it real quick. You got pi times negative 1/2 minus 1 is negative 3/2. So the answer is negative . If you caught me, I missed a negative back here. Negative 1/2 minus negative 1. Because when you plug the 1 in, you get negative 1 over x. There's the negative that I missed. So minus negative 1 would give us negative 1/2 plus 1, or positive 1/2. So our answer is pi over 2. That's the volume of the solid. The next problem in your homework is number 19, and you're rotating region 1 about OA, which turns out to be the x-axis. So if we look at region 1, it's this easy region right here. from 0 to 1. And what's the radius of my disk? I'll put the pi out here again. The radius of my disk is x cubed, because it shows us right here that that line is y equals x cubed. And this one's pretty easy for you to evaluate. So simplifying it first, you've got pi times the integral from 0 to 1 of x to the 6th dx. We integrate that, we get x to the 7th over 7, or 1/7 x to the 7th. So pi times that, evaluated at 1, would be 1/7 times pi. Pi over 7 is the volume of region 1 rotated around the x-axis.